Okay, so you're going to do the balanced versus unbalanced forces concept builder. You can click these arrows on the side to make your screen full screen. Go ahead and just type a name in here. Press start. I'll show you an example of each level. So here's an apprentice level, begin apprentice level. Right now I have a diagram below representing forces acting upon a rightward moving object. Each arrow represents a force. The length of the arrow represents the strength of the force. These arrows are the same length. So the up and down direction is balanced. This arrow does not have an arrow balancing it in the other direction. So I'm actually going to go down here and select unbalanced first. Now, it says the object is moving to the right. Do you see that? So if you are moving right and being pulled to the right, this is a pull, right? Or push. So rightward motion plus a rightward force means you are speeding up. Okay, so a diagram below represents a force moving on an upward object. Okay, this object is apparently moving up. Let's look at those forces first. We have a downward and an upward, but they're not the same size, so we're going to click unbalanced. Once you click unbalanced, the only two options are speeding up or slowing down. So now our upward force is bigger. So we're moving up from the problem statement and being pulled up. We are speeding up. Okay, let me show you one at the master level. Here, remember the simulation that I'd run for you in class with the green ball and the red ball? Or your ticker tape labs? This is a sample ticker tape. So you can see in the ticker tape that the object starts out moving at a slower velocity and then increases velocity to the right. So this object is speeding up because you can see that the dots are getting further apart and is moving to the right. So it must be experiencing unbalanced forces. Okay, here's an example on the wizard level. The motion of an object represented by velocity and time data. So here you have a change in velocity of v final minus v initial over time, 1 second, a delta v of -2. And that happens every single time. So this object is getting faster and faster and faster and going in the negative direction. Our object is getting faster, although it is moving backwards. So we are speeding up. We have an acceleration because we have a delta v. So unbalanced. Here's one with a position and time graph. So it says that an object's moving right and they're represented by this graph. So here we want to think, is this graph showing acceleration? Remember what it means for a graph to show acceleration. For a position graph to show acceleration, you might see part of a smiley face, because that means that the slope is increasing in size. You might also see a frowny face, which means that the slope is getting more and more negative with time. So what we're looking for is if there's a smiley or frowny face shape, not something that is emotionless. Do you see that here? If so, then we have acceleration and unbalanced forces. Okay, good luck.